Here's the problem we're working on. Let me show you a couple of different ways to approach it. One way would be to convert the cosecant and the cotangent into more familiar equivalents, such as the cosecant is 1 over the sine, therefore the cosecant squared is 1 over the sine squared, and to make a similar replacement for cotangent and cotangent squared. Now, one way you could continue here, and I say that because I'm going to show you a different way in a moment, but you could just use your unit circle knowledge now that you've converted down to this, and plug in what you know to be the sine of 5 pi over 6 and the cosine of 5 pi over 6. For example, at this point, you should know that the sine of 5 pi over 6 is a half, and that the cosine of 5 pi over 6 is negative radical 3 over 2. At this point, what you've got is a very messy algebra problem, which I did the work here, and if you'd like to look at it, you can see that the answer is 1. Hit pause if you want to examine this more closely, and I'll continue. A different way to do this problem, which I think is a little bit more clever, would be at this step here, after the first change of identities, or change of functions using identities, you could have realized, as I did, that, oh, I'm subtracting fractions here, and I already have a common denominator. So rather than plug in the actual known values for sine and cosine of 5 pi over 6, I exploited the fact that I have a common denominator here, and therefore can merge into one fraction with that denominator. Which doesn't sound particularly helpful until you realize that now the numerator is itself simplifiable. One of our many identities is that 1 minus cosine squared of any arc is sine squared of that same arc. And while one doesn't have to work it out this way, the benefit is that if you did, you get down here and you realize, oh, third grade rule, anything divided by itself is 1, therefore the answer to this thing must be 1. A slightly more efficient way to do it. In fact, this method, I never actually thought about the arc 5 pi over 6, nor its trigonometric values. In some sense, if I were to replace all the 5 pi over 6's in this problem with a random variable, say theta, then I've essentially proved an identity that is, which means that this expression would always work out to 1 no matter what theta were. And that completes the problem.